Every map you've ever seen is a lie. Not because of conspiracy, not because of NASA, but what if the flat map was right all along? Today, we're not arguing with conspiracy theorists. We're doing something far more dangerous. We're taking the idea seriously. Before we continue, your question for today. If the Earth were flat, which ocean disappears first and why? Drop your answer below. And if you're new here, subscribe, because this is where we break reality scientifically. Let's be precise. When scientists model a flat Earth, they don't imagine a floating dinner plate in space. They model a disk, roughly 40,000 kilometers in diameter, the North Pole at the center, Antarctica, not a continent, but a massive 60-meter ice wall running along the entire outer edge, holding everything in. The Sun and Moon? In this model, they're not 150 million kilometers away. They're small, close, moving in circles above the disk like a spotlight, illuminating different sections as they rotate. Sounds absurd? Good, because when we run real physics against this model, absurd is just the beginning. Gravity, the first thing that breaks. Gravity is where the flat Earth model doesn't just struggle, it collapses. Here's why. Gravity isn't a preference. It isn't a setting you can adjust. It's a fundamental consequence of mass, and mass, when given enough of it, always pulls itself into a sphere. It's called hydrostatic equilibrium, and it's the reason every single large object in the observable universe above a certain mass is round. Planets, stars, moons, all spheres, always. But let's suspend that. Let's say, hypothetically, flat gravity exists. In a disk model, gravity would have to pull straight down, toward the center of the disk, not toward a core. This means gravity would be uniform across the entire surface, only at the very center. The further you move toward the edges, toward that ice wall, the more the gravitational pull would tilt. You wouldn't feel pulled down, you'd feel pulled inward toward the North Pole. Walking toward the edge of the world wouldn't feel like walking on flat ground, it would feel like walking uphill forever. And here's the terrifying part. At the outer edges, near that ice wall, the angular difference in gravitational direction would be so extreme that standing upright would be physically impossible. You'd be leaning at an angle. Buildings couldn't be built vertically. Rivers wouldn't know which way to flow. The edge of the flat Earth wouldn't be dramatic. It would just be wrong in every physical sense of the word. Now let's talk about water. Because water doesn't care about theory. Water follows gravity, perfectly, ruthlessly, without exception. On a sphere, gravity pulls everything toward the core, which is why oceans curve, why water finds its level globally, why the sea off the coast of Japan and the sea off the coast of Brazil are both down, even though they're on opposite sides of the planet. On a flat disk with tilted gravity pulling toward the center, water would migrate, slowly at first, then catastrophically. Every ocean, every sea, every lake on the outer half of the disk would begin creeping inward toward the North Pole. The Pacific would drain toward the Arctic, the Indian Ocean would shrink from its southern edges, the Atlantic's southern half would become a shallow, dying basin of receding tide. And at the center, the North Pole wouldn't be ice. It would be the deepest ocean in human history, a single, massive, converging body of water, hundreds of kilometers deep, fed by every river, every glacier, every ocean on the planet, all pulled to the same point. Meanwhile, the outer edges, the lands near that ice wall, desert, bone dry, not because of climate, but because physics stole all the water. Australia, the southern tip of South America, the bottom of Africa, they wouldn't just be dry, they wouldn't be habitable. Here's something nobody talks about in flat Earth discussions. Air. The atmosphere isn't just weather, it's a pressurized shell held in place by, you guessed it, gravity. On a sphere, gravity holds the atmosphere uniformly from all sides, like shrink wrap around the planet. On a flat disk, the atmosphere would behave like liquid on a tilted table. It would pool toward the center. The edges of the disk would have thinner and thinner air the further out you go, not because of altitude, but because of gravitational geometry. By the time you reached the outer third of the disk, the air pressure would be similar to standing at 8,000 meters on a mountain. You couldn't breathe near the edge of the flat Earth, not with oxygen equipment. And beyond that, the disk would have no protection from solar radiation on its underside. A sphere deflects and distributes radiation through its magnetic field, generated by its spinning molten core. A flat disk has no mechanism for that. The bottom of the flat Earth, whatever exists beneath it, would be constantly bombarded by cosmic radiation, solar winds, and charged particles. Nothing could live there. The flat Earth, scientifically, is not just wrong, it's lethal. Let's move fast here, because this is where flat Earth theory gets truly humiliated by technology. GPS works because of triangulation, signals from multiple satellites at known orbital positions, calculating your location based on signal delay. This math only works on a sphere. If the Earth were flat, every GPS calculation on the planet would be wrong, not by meters, but by thousands of kilometers. Your Google Maps would tell you you're in the middle of the ocean when you're standing in your kitchen. But GPS works perfectly for 8 billion people every single day. The satellites themselves, 4,700 of them currently orbiting Earth, follow elliptical paths that are only possible around a spherical gravitational body. Orbit around a flat disk is not just difficult to maintain, it's geometrically incoherent. The gravitational field of a disk doesn't create stable orbital shells. Every satellite launched would either escape into deep space or spiral inward and crash. There would be no satellites on a flat Earth, no GPS, no satellite phones, no weather forecasting, no Google Earth, and the irony of that last one should not be lost on anyone. Here's what this thought experiment actually reveals. The Earth being a sphere isn't a belief. It isn't a theory NASA invented to sell rockets. It's a consequence, a mathematical, physical, unavoidable consequence of gravity, mass, rotation, and time. The sphere isn't a shape someone chose for Earth. It's the shape that physics demands. And the fact that we live on it, that we evolved on it, built cities on it, sailed across it, launched satellites above it, all of that works because the physics is consistent, because the sphere is real. The flat Earth is not just scientifically wrong, it's a world where oceans drain toward the poles, where the edges of civilization are airless deserts, where satellites can't orbit and GPS doesn't function, and the sky itself becomes hostile the further from center you go. It's not a simpler world, it's a broken one. And the most extraordinary thing about the real Earth, our sphere, is not that it's round, it's that it's exactly the right shape for everything we know to exist, including us. So, back to the question, which ocean disappears first on a flat Earth? I already know what I think, but the comments are yours.